Okay, so Max was giving you this overview of safe system principles and just a little bit of thinking about energy management and what forces the human body can handle, and thinking a little bit about so other elements of the safe system. So for some of you, it's a bit of a reminder, a bit of refresh, a bit of, okay, we're all on the same page now. We've got those general ideas. Some of you might have been getting a few new thoughts there. I think there was a lagging question that people that they didn't get to, which was associated with sort of the effectiveness of some of the vehicle technology features coming in. Auto emergency braking, lane keep assist, electronic stability control and the like. I don't have the figures immediately at hand. I know that there's some different studies from some of the universities that sort of show, if you turned over the whole fleet, you would expect, we'd get sort of 20% reduction, 30% reduction in fatal serious injuries and these sorts of things. So I can sort of dig in to find a little bit of those specifics if anybody wants, and send those reports through. I mean, a lot of the modeling in road safety and a lot of the ways we look about it recognizes that the vehicles will play a big role into the future, but recognizes that there's still a major amount of trauma that will occur even with the newest vehicles that we sort of have at the moment. Okay, maybe in another 10 years, the newest vehicles are really going to have got us there, but you need to factor in also the turnover of the fleet, which is sort of it's 15-year turnover of 20 years to get the turnover of the fleet. So we've got, we're talking 30 years worth of death and serious injury at reasonably high rates if we're just going to sit on our hands and wait for the vehicles to fix everything. So we still... a lot of the jurisdictions do studies into, should we just be investing in car vehicle features and just ignore the very expensive infrastructure type treatments, and it always comes out that infrastructure is still a very good and worthwhile investment and sustainable investment, and we need to encourage more improvements in the fleet. Anyway. So back to speed now, and Max was talking a little bit about, some speed fundamentals in terms of the impact forces at different speeds, but also reaction time, braking distance, the power relationship between speed and injuries, so that it's not a linear relationship. And we know that, speed is hugely important, but it's very, very challenging, especially if we're talking speed limits. Using infrastructure like local area traffic management or other features on the network that have physical characteristics that people slow down as they approach these areas by themselves, it's their choice to do that, they are very effective. And speed limits can be effective, but they come with a whole lot of challenges, and we have a very big reliance on the drivers themselves actually complying. If you put a speed hump in a road, okay, you can have whatever speed sort of limit you want, as long as the driver knows it's there and knows it's coming up and is fully aware of it, they will slow down. So it's very, very effective from that perspective. So we know that you can achieve safe travel speeds through infrastructure and or speed limits. I encourage any way you possibly can to use infrastructure as much as you can, because of the challenges that come with speed limits. Speed limits are very important, but we need to be really coordinated and targeted about how we go about speed limit management. I think we've completely got it wrong in Australia in terms of speed limit management in the past, and we need a reset. But you're taking a whole community on board, you're taking the politics into account, you're taking all sorts of other very complex things, and they intertwine, and it's really, really challenging. I had the pleasure or the displeasure maybe of managing speed zones in Victoria for a handful of years, and all of speed limit policy and everything like that, and have worked on speed zone policies across Australia. And yeah, it's very complicated. It sounds easy, but it's one of those ones, the more you get into it, it just becomes incredibly complex. But happy to share lots and lots of research and documentation, amazing studies. If anybody's interested in that level of, holistic change in speed zoning and speed zoning practices. I mean, just one like little anecdote I'd like to share, which is, okay, in Sweden, the default speed limit is 70 kilometers per hour. And if you can prove that a road has satisfactory safety performance, it can be raised up from that 70. This is the rural road network. Okay. In Australia, we have 100 default. And if it's unsafe, which is often, if enough people are killed and seriously injured, we might consider bringing the speed down, right? Like that to me is just like, if anybody ever says we're safety first, that's just proof we're not. We're about some okay, when's it, what amount of our community killed and seriously injured is enough to warrant us thinking about doing something. So, there's an example of where we've sort of stuffed it up. But as I said, it's so complex with politics, with the fact that that's what everybody's used to, with another one, which actually is really important too. And I'm already going off script here. And I have told a couple of you this in other courses in the past, but I think it's a really important thing for people to know. If you've got risk on this axis, and you've got like a rural road, and it's currently 100 kilometers per hour. Sorry, I'm using a mouse to try to do this, not a touch screen, which is a bit of a challenge, but hey, I'm doing actually pretty well. Okay, so you've got a road and there's a 100 speed limit, or it's 80 speed limit. Okay, this is a rural road. Now, for an individual driver driving that road at 100 or driving it at 80, we know the risk level for that individual at 100 is there, and at 80 is there. All right. There is a very, very small risk for the individual driving the road at 100, and driving the road at 80 is a very, very small risk, and a tiny little bit smaller. But it is that these risk levels are so small that at an individual level, you cannot possibly conceive the risk change. Okay, so if though we add up those small bits of risk for all of the drivers on that road, and another one, and a few thousand a day, all of a sudden we get a risk profile at 100 kilometers per hour up there, and we get a risk profile at 80 kilometers there. And you've got an actual significant difference in risk at the collective level for everybody, for our community. Okay, but the issue we have a lot with speed zones and speed limiting is that we talk to the individuals like they're a collective. And we say, oh, we're reducing the speed limit on this road from 100 to 80 for safety, for your safety. They're like, what? I've been driving this road for 40 years and I've never had an issue. What are you on about? And I don't blame them at all. I mean, that's, very low risk to very low risk for them as an individual. So anyway, I think we need to think about the way we talk about speed zone changes. The science and the theory on it is unquestionable that a lower speed limit on a road improves safety. I was rewriting the Austroads Guide to Road Safety Part 3, which is speed limits and speed management. And I just put in there 30 studies before and after of roads where the speed limit had been dropped and safety had improved, and then roads where the speed limit had been increased and death and serious injury increased. And like, it's just, there's so much information out there to back this up, but it comes with those challenges. Okay, so I think, Marissa, is it? I see chat activity happening on.
Yeah, we have a couple comments or questions. The latest version of the speed zoning guidelines in Victoria has introduced risk rating as a reason to reduce speed limits on open roads.
So this is a much better way to move, and certainly a risk rating system like IRR, this infrastructure risk rating, or even utilizing OSRAP, ANRAM, any of these ways to assess infrastructure for risk, and then apply appropriate speeds is very good. You certainly shouldn't be waiting just for enough people to be killed before you intervene. But I do think that we are still operating from the perspective of speeds are high, prove to us why they should be lower. Not, we're gonna make things safe and go as fast as we can within a safe envelope. But I'm not saying it's an easy thing, and it's very much not. I certainly didn't fix it in my time, and I tried some different things, and it's challenging. Anyway, some more questions?
Yeah, we have a question. Does that mean very low volume roads should have unlimited speed for no significant risk increase?
Yeah, so that's from an exposure perspective, and the answer to that is, yeah, at an individual level. If you took that collective in its absolute, some goat track that has one person occasionally could have very high speeds because the chance of that would be low. The real reality of it, though, is that the impact on the collective in terms of other movement functions is also very low. So again, we should be opting for the safe option. And those are actually theoretically easier because you're not impacting a lot of people from their mobility by implementing lower speed zones. But it's a fair use of my argument back against me. So well played. But yeah, the basics around theoretically managing speed zones in an area is to have a default low speed limit and look at the roads that have appropriate infrastructure and raise the speed on them, and that should go across all traffic volumes. And naturally, you'll put your better infrastructure into the roads with higher traffic volumes. But yeah, boiling down major complexity to simple statements. Anyway.
Thanks, Ken. We have a comment. Freeways are supposed to be safer roads, but tongue twister, paradoxically also have the more crashes. Obviously, a factor of high volumes, thus the collective impact.
Yeah, well, and that's right. I mean, yeah. And we'll see, actually, this is a nice lead into how we do a safe system assessment, because we factor exposure in with likelihood and severity, and we come out with sort of risk levels at a collective level. So I'll talk a little bit more about that, but Andrew's hit the nail on the head there. And yes, Ross is madly working hard to try to get us safer speed zoning across Victoria, and yeah, we're making progress. I better keep moving.
Thanks.
Just a couple of little things I think are interesting. Generally explaining why a speed limit is in place, assist with compliance, or acceptance and compliance, especially around vulnerable road users, and pointing out that, I mean, people will grumble, they'll always grumble at it, but when it's very clear why a speed zone is in place, it's quite, it's better, it's better accepted. And vulnerable road users, as I said. So I actually think speed zoning in urban areas, we have a lot more ability to make changes with some good justification around livability, increasing active transport, health impacts, noise, all sorts of good things. There's a lot to play with. Rural areas, it's sort of this safety versus mobility aspect, and I'm always trying to throw in other factors, be it fuel consumption and resulting tailpipe emissions, whether it's protection of wildlife, noise again, you can sometimes latch onto. So try to look for more levers. Variable speed zones, though, for me, play we should be increasing and playing more and more of a role using them more, because I see them as a way to start accepting, people start to accept speed zone lowered, because it's trying to tailor it at a specific time of day and time of risk. I said time of day, but that's because there was risk at that time of day more than at other times. But certainly the rural intersection speed limiting, so the different, it's got more names than any infrastructure I've ever heard. So the side road activated speeds or the like, is where you've got the main road and it's at a certain speed, but then if a car's coming in on the side road, it'll trigger a lower speed limit on the main road. And that to me is sort of beautiful way to get people a bit more accepting of some of these lower speed limits, and it's good use of technology. So we'd like to see that spread more across Australia, and it might be that in your safe system assessments you're recommending these if you're in a jurisdiction that hasn't used this, and you can push people into like trialing some things and a bit of innovation. And there's the key points in there which you can look at in your own time, because you've got the PDF notes which you can download from the learning management system. Right. Now, Marissa, let's give a prize if somebody can give me the international definition of risk. International formula for risk. I wonder if anybody's got that at their fingertips. Pause and see. Oh, so Andrew's gone next level and given us the safe system assessment definition formula for risk. But Braden's in there. Probability times severity will do as that one. So you better give a prize for two here. So likelihood times consequence, but I'll also take exposure times likelihood times consequence, or likelihood times severity, or probability times severity. So it's what is the chance a crash is going to happen and how bad is it going to be, right? But this is also like, economic risk. What is the risk of recession? Well, the risk of recession is what is the chance we go into recession, and then what depth of recession are we going to go into? That's the risk of recession. So recession's a bad one to use there because it has a particular, or health risk. What's the, what's the chance of a disease, and then how bad is that disease when it goes out there? Is everybody just going to get a light cold, or are we going to, have people, large swathes of our population dying? That's the risk of that of that disease. So we use that in road safety. We've used it for a long time. We've said, what's the chance of a crash? And then when it does happen, what's the severity of that going to be? We've often, as an industry, really just, whoa, what did I do there? Really just focused on the likelihood one in road safety. And if it was convenient, thought about consequence. But what we're changing under the SAFE system is to really say, no, consequence is super important. We need to think about it. We need to understand what can we do to influence how bad crashes are when they do occur. And not say, oh, well, we'll try to stop all crashes happening, because we know we've got humans, they're driving vehicles, they're walking around the road, they're riding bikes, and humans are going to make mistakes. They're going to crash. They're going to fall asleep. They're going to, be distracted by stuff, drop their coffee in their lap. They're going to, all like the list of things that could go wrong are just is infinite, right? But we can manage these crashes so people hopefully walk away from them because we've managed the energy. So for a safe system assessment, we talk about, well, hang on a second, likelihood's kind of made up of two things, isn't it? I just talked about it with those speed limits on the 100K road and the 80K road, the same road, 100Ks or 80Ks. What exposure is the number of people going through this area. Okay. The likelihood is about the physical infrastructure. It's about the characteristics of the infrastructure and the speed that make up the chance of the crash. And consequence stays as consequence, because you're putting yourself in a mindset that the crash now is happening and we've got to work out how bad it's going to be. So to do a safe system assessment, we do this. We actually quantify the exposure to crashes, the likelihood of crashes, and the severity, the consequence of the crash. We put a number to it and we get some numbers out here. And that's what we're going to be building to, and then we're going to get you out there looking at the road environment and analysing, well, what's the exposure crashes? How many road users are exposed to crashes here? And then what's the chance that they're going to crash? And then how bad are they? What are the severity of injury when that crash happens? So just to sort of help you get this clear in your mind, exposure, likelihood, and severity, I'll show some treatment end stuff where we go that are influencing the exposure to crashes or the likelihood of crashes or the severity of crashes. Now take note here, because your assignment at the end of this module, we're going to ask you to do this, to look at a little bit of the road network and think about what's influencing exposure to crashes, what's influencing the likelihood of crashes, and what's influencing the severity of crashes. So here we're talking about exposure, and it's a bit hard to see there, but there's a level crossing and there's a big mound of dirt and a road closed sign over the other side here. So this is stopping any vehicles crossing the level crossing. Thus, we are not exposing anybody to that crash, train to vehicle. There is no exposure, okay? So closing a road, an intersection or the like, you eliminate that exposure. But likewise, if you physically separate, and I'm talking about physical separation here, not just like a line, a white line or a little bit of curb or something like that. If you physically separate, say on this one, we've got cyclists and pedestrians physically separated from this elevated structure which has all the cars, the cyclists and pedestrians are not exposed to crashes with passenger vehicles. Okay, they might be exposed to crashes between each other, like cyclist to pedestrian, but not vehicles to cyclists or pedestrian crashes. So those are sort of examples of where we've addressed exposure. Now, likelihood of crash is influenced by a lot of stuff we've done for a very long time in road safety, like line marking, sealed shoulders, good pavement, lighting, some things that are a little bit newer, like wide center lines, audio tactile edge lines, RRPMs, even just good geometric alignment of a road is a likelihood factor. Okay, these are all things trying to stop people crashing in the first place. Let's do everything we can to stop people crashing. Even traffic signals themselves, they are a likelihood factor. Okay, we reduce the likelihood of people crashing if we signalize an intersection compared to a passively controlled, so like a give way or stop sign. They're less likely to crash because they're getting a clear indication, okay, you stop now and you go now, and vice versa. But if somebody decides to not take that advice, or misses it completely, or is distracted, or is half asleep, or the like, the severity of the incident is just going to be as bad as it was before, because we've got same speed, right? We've got same crash angles. The severity is just as bad. Now, there will be some cases where the severity is down because, you know, they've slammed on the brakes late and they go into the intersection slower, but we still have abundant capability for high severity crashes to occur at these signalized intersections. Okay, but the feature of the signals itself does reduce the chance of crash. Then we talk about severity. Well, we only have a small handful of things that can actually substantially change the severity of crashes, because we're down to the physics and biomechanics of injury here. Okay. And really what we've got to play with from a road design perspective and road management perspective is the speed of vehicles, the angle of impact if you're talking about vehicle-to-vehicle crashes, so the angles that they hit and the types of crashes that will occur, and then, yeah, so we've got speeds, angles, and the types of users you're letting into these areas. So, you know, if we have pedestrians, the severity will be much higher compared to vehicles, and so you've got that sort of interplay. Sometimes we also have the ability to implement features that manage energy, and that's particularly what they're designed for, such as barrier systems, crash cushions, impact attenuators, you know, cushioning devices. So, you know, if you've got barrier systems, they are a really good example of a severity reduction device, because if a vehicle leaves their lane here and they're going along and they leave their lane and they hit this barrier system, that is a crash. Okay, but we know the severity of that crash will be low. Without the barrier system there's a fair chance that they would go into the other lane, there wouldn't be any other vehicle, they'd come back, they'd drive on, there wouldn't be any crash. So actually with barrier systems, the installation of that system increases the likelihood of crashes. But the severity of any crashes happening is so much lower because those products are designed to manage that energy. So you can see there, we have the ability to influence exposure or likelihood or severity or combinations of all of it by choices we make with the design and the management of the transport system. We can take human behavior like almost out of this equation, because there are ways we can sort of redesign the road for the bulk of the death and serious injury that occurs. Okay, there's practical challenges associated with funding and getting community on board, but at that pure design, engineering, and management of the system perspective, yeah, we can do a huge amount in reducing death and serious injury still. And what we do with safe system assessments is really utilize those to present this to our clients. Could be road authorities, could be designers, could be others who have an interest in this logical manner of saying, well, you know, here's the exposure to crashes, here's the likelihood of crashes, and here's the severity of crashes, and here's some things that could be done to lessen that. So Marissa, I'll grab questions in a second, because I think this is about the point where we get to where I get to start module 2. So I was just catching up there. Any questions?
We have one question at the moment. Could a motorist miss a safety ramp just as easily as a traffic signal while also introducing a vehicle stability issue if hit at speed?
Yeah, that's a really important sort of question, and it's asked by a lot of people associated with raised platforms and the like. And it's very much been proven that that is not the case, and people do not miss raised platforms. Okay, there's some requirements with that. They need to be marked well, and they need to be lit, and they need to have, you know, some advanced warning signage if you want to supplement. But you know, the evaluations that have been done on raised platforms in lots of different road environments show they are extremely successful, and people are not hitting them at speed. Well, anybody who's hitting it at speed seems to be fully aware that they're going to hit it at speed. So it's not a and that is so rare that somebody has decided to go. I mean, we're talking like police chase type scenarios. But it's a good question to ask, and I'll show you a few things around that a little bit later in this module. So thanks, good question. Okay, so I'm going to get everybody to do a little exercise soon, and I'll utilize that as an opportunity for everybody to fill up a coffee and have a stretch as well. But this module, we're delving in further into that kinetic energy management and kinetic energy thresholds at intersections. And we're going to look for characteristics of intersections that align highly with safe system principles, and that maybe don't align so well, and same for mid-blocks. And just a little note on language here. All right. You notice that I always say, you know, that aligns highly with safe system principles, or that doesn't align so well with safe system principles. I don't say that's safe system or that's not safe system, because the safe system is this sort of, I suppose, utopian, not utopian, but it's you know, it's something off there that is absolutely, you know, free of risk through addressing exposure likelihood or severity. And I know the bulk of the network is nowhere near that. And what we're doing is trying to move the dial significantly over towards that alignment. Okay. Now, a bit of, you know, there's a bit of irony in that sense that I happened to start a company that was called Safe System Solutions, but it's things that we know align highly with safe system principles in that sense. But anyway, just note that, and it really, actually, it's part of the reason safe system assessments came about was that we had the emergence of people arguing, you know, oh, well, that's not safe system, or that is safe system. And then whole programs coming out saying, you know, we will only do safe system features, you know, in this program. And you're like, well, what does that actually mean? Is it safe system for motorcyclists? Is that, you know, okay, well, you're doing that on that road, but have you thought about pedestrians? Is that going to be safe system for them? Like, so I always just talk about that alignment, and we'll show you how the assessment technique, which you're going to learn, is all about, you know, saying, where are we in that alignment? How well are we aligning things with safe system principles? And so we're going to start with intersections. And an intersection is a fascinating point on the road network, and I'm sure you all think of the risks at intersections quite well, and you're thinking about that type of crash that you see on screen, or maybe you're thinking about a pedestrian crossing and somebody turning over that pedestrian, and these are all risks we see at intersections. Maybe bikes going through, or even motorbikes involved. Okay, so these are all the intersection crash types associated with a particular conflict points. Now, conflict points is that if you draw a line of travel path and two road users cross that travel path. That's the point where the crash can happen. There are conflict points, okay? But there's another area, another reason why risk goes up at intersections, and that's associated with secondary crashes and avoiding crashes. So as a vehicle approaches an intersection, another vehicle could enter that intersection, and then the vehicle will try to avoid, as you naturally would. If you're driving along and you're approaching an intersection and somebody pulls out, you're going to try to avoid if you can. And then vehicles leave the road. And they may clip the other vehicle, and so you've got these sort of secondary crashes that are occurring. And we also put point source hazards all around intersections. So at signalized intersections, we've got signal pedestals, rigid signal pedestals we put around the intersection. We've got often culverts because you need to drain water through these areas. We've got power poles because maybe you need to turn the power line down a road, don't you? We've got lighting. So we actually place a lot of roadside hazards around a location with increased chance that people will leave the road. So we're increasing the likelihood of crash because there's turbulence, there's conflict points, it's all happening there. And the severity has gone up because point source hazards, they're not getting these cleared areas or often barrier systems. So important to think about all of that as you're looking at intersections when you're doing your assessments. So Monash University Accident Research Centre came up with some general principles of intersection design to get better alignment with safe system principles. Now, this is very high level, very theoretical, and very sort of, but what I suppose is interesting is that the first two here, fewer vehicles and fewer intersections, they're associated with the exposure to crashes. So less people exposed to intersection crashes. Then we get in and we're looking at, okay, well, the chance of crash through conflict point and minimizing conflict points, maybe left in, left out, or closing off a turn or the like. And then we've got all of the severity stuff and managing the energy using speeds and angles to try to lessen the energy of any crash. And you can see there that they've sort of placed these within those safe system tolerances that Max talked about last session, and the speeds that you expect your community to survive at in different crash types. And so I won't read through them all in details because I think I've got a couple of tables, which makes it a little bit easier. But you can see there, I'm starting here with passenger vehicle to passenger vehicle crashes, okay? So for now, we're just going to put pedestrians and cyclists aside. Maybe we're thinking about rural environments here. We will talk a lot about pedestrians and cyclists at intersections and how to, get us our best safe system alignment there. But passenger vehicle to passenger vehicle, we can generally have all crash types occurring where we have a speed differential of 40 kilometers an hour and expect our community to walk away from that crash or just have sort of minor injuries where we don't want it to happen, but it's generally survivable. And it gets up to that 50 kilometer per hour for that right angle impact. If you get more angle on the crash, you can go up to about 60 kilometer per hour where we're still generally thinking people are it's quite survivable. So if you can have your crashes occurring at sort of these angles, okay, we know a lot of the energy is dissipated out into the environment because they kind of bounce off each other a bit, and it's a more survivable crash, and somewhere up to around 60 kilometers per hour for that. 70 for your head-ons, and 80 is really talked about under this as not feasible. You cannot operate an intersection with 80 kilometer per hour delta V. And it's important that I talk about delta V, which is change in velocity, because you can operate an intersection at very high speed if you want, but you need to accelerate vehicles so that their differential speed is within tolerable ranges. So, and the easy example of that is like an on-ramp or something like that. You accelerate the vehicle up. So if they were to crash there, it can happen at 100 kilometers an hour. It can happen at 300 kilometers an hour. That's, they can crash into each other. The transfer of energy in that initial incident is not enough to cause death or serious injury. Now, if it's high speed, you've got to think about secondary crash at these, because people are going to run off the road, and then we're into major energy territory. But the actual initial crash is within tolerable levels. So when you're assessing an intersection, you want to think about the angles of crashes and the speeds. Now, you don't need to be this precise, but when you're doing a safe system assessment, you can simply go, well, okay, a vehicle pulling out there and being struck by another vehicle. I'm just going to change color here. Is sort of, that's about a 90-degree crash. So we're thinking around the 50 kilometer per hour bullet vehicle speeds, about what we're worried about. Maybe over this side, okay, there's a bit more bounce off, so we're up around the 60 kilometer per hour mark. So, you're thinking about angles, speeds, and the vehicles involved. And this is pretty much the equation we starting to think about for how bad's that crash going to be when it does happen. And I talked about the secondary crash impact. We want to think about that. We want to think about vehicles leaving the road as well at these intersections and what's around them. And the Centre for Automotive Safety Research at the University of Adelaide did a big study into secondary crashes at intersections, which was interesting. Came out with one of the outputs within their Big Juicy report, sort of replotted all these intersection crashes onto the same axes: vehicle, crash, secondary, death and serious injury, out in striking objects and rollover and all of that in these areas. Probably pretty obvious, isn't it? Do we need a big juicy academic study to tell us that? Probably not, but nonetheless, it's there. Okay, so I'll pause there before I introduce this exercise and see if anybody needed any clarification on any of that.
We have a question from earlier. How do we instill safe system thinking to external parties when their thinking is more based on capacity requirement, example, land use development?
Interesting big question to ask. I first of all would say that I actually believe we can get safety to be more of a marketing tool than we currently do in development. I think there's a sales pitch to a safe development that is underutilized. I think it's sort of similar to ANCAP star ratings of cars, like where we used to go, oh, what sells a car? Well, the faster it can go, the more cup holders, the color, the awesome, whatever other feature it had. And you just had the, Volvo, would occasionally, talk about their safety features, which then was some sort of fringe weirdo who bought a Volvo for safety. But ANCAP proved, and star rating of cars proved, that you can actually leverage a huge market on safety and people demanding safety and wanting safety and buying for safety if you frame it in the right way. And so I think we can go in with the big stick and try to force developers to do things that, frankly, the road authorities aren't doing themselves, right, in a lot of cases. And the developer's just going to go, really? You're going to make me spend that extra money, and the intersection down the road, you're not doing it. So I think we're a bit, I think that's a bit harsh for us to start that way. And what I do is be out there star rating and making public their developments and their intersection, like their access to the network and how they've done that. And you can have those conversations and we could go, here's a big new subdivision built by, luxury subdivisions. It has a 1-star safety record for pedestrians, a 1-star safety record, safety rating for pedestrians, a 1-star for cyclists, and a 2-star for people in vehicles. Done. Publicize that. They're not going to be happy, but it's going to start developers going, well, yeah, we want to be able to say this is a safe community, as well as, you know, a community that has good active transport and all of the other things, and, you know, security and things like that. So I think that from that perspective, we could reframe discussions with developers as a sales advantage rather than just an onerous road authority putting more restrictions on them. So that's one thing. The second is to utilize things like the Safe System Assessment Framework, which have a genuine sort of ability to put down something independent that says some things about the safety. And then we can really start to push more and more associated with road authorities' decisions around safety features.
Thanks, Ken. And Damien has just said on that, our local developers are only interested in yield.
And like I was a development, I was not a developer, that's for sure. I was a planning manager in Vic Roads for quite a number of years, and so all the development applications were coming through our area, and so I certainly know that. But as I say, like I never begrudge a developer for wanting to make money. I mean, that's what they want to do. Like, that's what they're there for. It's kind of like our job to get it so either they make less money if they're not going to be safe, so you incentivize them from that perspective, as I was talking about before, or in a lot of cases we stand firm to what we know is going to be a safer outcome if that's appropriate for us to put those constraints. But as I say, as a road authority, I really feel we've got to get our yard in order before starting to get onto the developers. Don't get me wrong, there's a lot in there the developers are doing that I think absolutely needs to be cracked down on, and spent my fair share of time in VCAT, which is Victorian Civil Administrative Tribunal against developers who are trying to push things completely unacceptable. But we need to do that. Okay, some more questions are coming in here. I've managed to bring it up now on my screen. Matt
has written, and I don't know what this means. You might, Ken, LXRA?
Yeah, Level Crossing Removal Authority, yeah.
Ranger Penny stickers is written there. All right, we've got a couple long ones. Brock, going a step beyond Safe System, did an audit for Lunch and Learn on the subdivision I live in and found SSD and SISD wasn't achieved at numerous intersections in subdivisions. Seemed related to maximising land yield. So councils, in this case, are missing Australian standard requirements. Getting SSA front of mind for everyone will be a long journey. And some consultants are missing not designing to standard. Council is missing that.
Yeah, so that's just unacceptable if you're not meeting basic like requirements. And what we're talking about, as Brock's exactly said, is like, you know, raising the whole bar on safety. And yeah, so that's very concerning.
Andy has asked, are there any intentions to legislate or enforce it so that road authorities undertake RSAs or SSAs on every project? It seems to be more of a provisional item, sometimes even given the benefits it can bring to a design.
Yeah, that's a good point. So this one is probably playing out in a more logical fashion across Australia, where we're seeing road authorities mandating safe system assessments and road safety audits on their projects and their programs, be that a congestion easing program or a public transport program or a safety program or whatever it is. These are being required and they're in their policy and they're being done. This is good, because once you've got that point, that's now something we can actually require on developers and say, okay, you need to do a safe system assessment on the concept of this development. And then once you're into detailed design, you need to do a road safety audit. And that's part of the planning permit provisions, and you just make it happen. And then you need to work on, what are the outcomes of it and which are they going to accept and not accept and these sort of things, but getting that actual practice to happen. So I think we're making steps forward in this. We'd like to see it accelerated a bit more, but I think we're moving along quite nicely. I mean, New South Wales has recently in their road safety strategy mandated safe system assessments. So that's an exciting publication. Queensland's been mandating it for a while for infrastructure projects, and Victoria was very early in the piece, as New Zealand was as well. So we've seen that, at least that eastern seaboard, mandating safe system assessments at different aspects of infrastructure projects. Road safety audits have been around a long time and are quite well integrated into a lot of the work we do. So we've got these processes, and I think we're going to see some exciting improvements. Good input. Thanks, everybody. Let's just do a little exercise. And as I say, I'm going to combine this exercise to give you some thinking time with your time to go get a coffee and have a stretch. So let me explain what the intersection exercise is. Okay, we've got a road here. It's a highway, and it's got about 21,000 vehicles per day. 21,000. It's major arterial or main arterial. It's got a right turn lane, you can see, into the side road. It's got a bus stop. This is a bus stop over here. This is like a shared user path. We've got an underpass here, not an underpass, so like a water culvert. It's not an underpass. Shouldn't have said that at all. It's a culvert. It's a culvert drainage structure. Residential area. Side road here is has got about 2,500 vehicles a day. It's got a 50 kilometre per hour speed limit. This road has a 70 kilometre per hour speed limit. What else can I tell you about this area? I've got some service roads here. They're just to provide access to these properties. They've got service road exits and entries back a bit further. About 500 metres up the road, here's a signalised intersection, quite far up there. And a couple of kilometres down the road's a signalised intersection as well. What else can we show you? Here's a bit of from the street. You can see there, we've got the bus stop over there. You've got this black car coming out of the side road. You can see the service roads on the side. See our vehicles going up and down here. If I jump over to the next the other direction, you see that drainage structure that the water goes through there and flows out there. Side road. So there's a shoulder which kind of doubles as a bit of bike lane as well. Okay, so your task here is to eliminate fatal and serious injury crashes. I'm going to give you an extra $1.5 million because I like you. You can have $4.5 million to eliminate death and serious injury at this location into the future. So some things. You can't close the intersection off, and you've got to leave access for people to come out and turn right, and to turn right in, and to come out left and go in left as well. So we need that full access for vehicles. You're also operating in the current political and organizational framework, you're in, or your road authority is in. So, if you're proposing something very extreme or the like, we would need a bit of justification. How are we going to get that through and convince people on that? But the most important thing about this is any treatment that you come up with, I want you to tell me, is that going to influence the exposure? So the number of people that are, that are there, and I'm going to put a little number symbol here just to really reinforce we're talking about numbers when we talk about exposure. Or are we influencing the likelihood of crashes, the chance somebody will crash? Or are we influencing how bad the crashes will be if they do occur? Okay, so let me give you an example. If I decided, okay, I'm going to improve the lighting at this location. Now, that would be very weird because you haven't seen it at night. You don't know anything about the existing lighting, but you would then type in improve the lighting and put a brackets L for likelihood, because improving the lighting at an intersection reduces the chance of a crash a bit. Okay, it doesn't do anything for severity or exposure. It reduces the likelihood of crash. Now, some of you are probably saying, well, I don't know how much stuff costs. And that's okay. I will be an instant cost estimator tool. So if you want to know the cost of something, you simply type in the chat, lighting improvement cost, ? And I'll say $200,000. And if you said, how about grade separation, a full flyover? And I'd say $54 million. Can't afford it. So I'm happy to cost estimate anything you want for this location, but your job over the next 7 minutes is going to be to type some ideas into the chat, ensure that you put exposure or likelihood or severity. That is the real meat of this exercise. What is the exposure? What is the likelihood? What is severity? And how can we make sure we get as close to elimination of death or serious injury at this location going forward? Try and keep it, generally within that $4.5 million budget. Happy for you to, have your own estimates on what things cost. You don't need to put a dollar figure in here. This is not a cost estimation training course. Does anybody have any questions about the intersection or the task you have ahead of you?
We have a question. Does the service road to the left have access at its other end?
Yeah, so both service roads have access, other access points. So that's a fair question.
No other questions at this stage? We'll take a break.
Yeah, so make sure you do have a stretch and fill up a coffee, and we're going to go for 6 minutes from now. No, 7 minutes from now. 7 minutes.
All right. See you in 7 minutes.
Okay, but do pop in any questions around cost if anybody's got it.
I'm not sure if that's a question, Damien. Are raised platforms on 70k roads outside guidelines?
I'll talk a little bit about that in a bit, but that's up to you for this stage if you want to look at that. And if you do, tell me if it's going to influence exposure or likelihood or severity.
All right. See you all in 7 minutes.
How much do the variable seed systems cost? Well, for this site to do something along those lines, we go 485,000.
For now. All right.
I think everybody's having their stretch break. I'm just going to go fill my coffee up, but be back shortly if anybody has any cost questions. Okay, let's make sure we all, wow, some good answers coming in here. I'm going to give it a minute before I start talking through. I'm going to read through everybody's answers while I can. Put in exposure and likelihood and severity. I'm seeing some really in-depth answers coming in, but I'm really keen on exposure, likelihood, and severity categorization for everything. Okay, sorry, I'm reading good answers and a few more I think still to pop theirs in, but I really did like what I'm seeing here. So looking at some reconfiguring of the service roads and the like, and that's all fine, and can help clean things up a little bit. Really, the major death and serious injury risk is not associated with that due to the fact that we don't have the speeds of vehicles there. It's those vehicles on that 70-kilometre-per-hour road that we'd think of as our bullet vehicles and the ones that are going to do the damage, and that's all a little bit outside of it. But yeah, nice to clean that up. We'd had some people talking about different configurations of signalised intersections, and signalised intersections are going to influence the likelihood. Now, I did see a couple of people wanting to put in exposure there. Okay, but that's not. Doesn't matter even like fully controlled right turns, it's still just a likelihood reducer. And that's because the same number of people, the same number of vehicles will be exposed to crashes. Now, okay, you might get some slight difference in terms of traffic modeling might show, okay, when you signalize it, a few more people might use it or a few more people might not use it. But generally, we talk about the exposures the same. The chance of crash is down, and the chance of crash is even further down if we've got fully controlled right turns. Okay, so we've got then people, and I really sort of like to see this, looking at how can we slow the vehicles on the high-speed road down at this particular location. So some people are looking at speed limit reductions in the area. Some people are looking at the variable side road activated speeds through there. And I think that's something that we absolutely should be thinking about. Can we do this in these urban environments? It's not done usually in these urban environments for all sorts of complex reasons, but we really, the theory is good there. Then we've got some people talking about roundabouts, which would reduce severity of crashes. That's good. And raised platforms, which could possibly reduce the severity of crashes. Some people making some good points about, well, we may be a little bit out of our budgets on some of our treatments. We've got some comprehensive ones. We've got some interesting discussions around slip lanes and if they were to be introduced, how they could be configured. These are good questions. Brock's given us a good dot point wish list, which I like. And I think prize for Brock for also making me laugh in there when point 5 was submit revised business case to get the $6 million to fund the above wish list. I thought that was quite funny because I was liking everything that was coming through there and well categorized as well. So it's and there's a lot of other good stuff. I'm not going to get through everybody's in terms of talking to them. I've read through as they're coming in, but I might talk a little bit about this in a slightly different manner. I'm going to I'll come back, I promise you, and I'll talk more about that specific intersection, but I just want to clarify a few of those things that people have been putting in and just make sure we're all on the same page. And I said it here that signals and signalization will influence the likelihood of crashes, and it does a good job. And you'll see, I'm using these symbols down the bottom here with a tick in what we're influencing. Signals likelihood, even with our fully controlled right turn, it's a likelihood influencing factor. And in fact, we know that signals give us about a 45% reduction in death and serious injury compared to a passively controlled giveaway intersection at a location kind of like that one. So that's, we know we get some good benefit there, but we've still got a residual there of 55%. And it's interesting then when you sort of overlay that and look at the death and serious injury across any major or even medium-sized cities, we see that the highest intersections for death and serious injury are signalized intersections and large signalized intersections. So here's a heat map of death and serious injury of just a little bit of outer metropolitan Melbourne. I could have really picked it anywhere. I could have picked Geelong. I could have picked Brisbane. I could have picked Canberra. It's when you've got these roads where the speeds are up above sort of 60 and above, and the major arterials and the intersections of those major arterials, and even some of the side roads as they get more volume, these are signalized intersections, right? That's where our community is being killed and seriously injured at intersections. Okay, some other intersections have problems, but if you list your top 100 intersections for death and serious injury in Greater Metropolitan Melbourne, Brisbane, Canberra, Sydney, you name it, the bulk of the top 100 are large signalized intersections. And there's this sort of general, our industry is completely off the mark, and somehow we feel that signalizing is the ultimate solution, maybe until you grade separate. But it's not the case. Professor Jeremy Woolley from the Centre for Automotive Safety Research at one point in a national forum said, traffic signals are the biggest failure of traffic engineers. And he meant it in the sense that traffic engineers just love getting those signals in, and then everything else, like after it's got mast arms and LEDs and speed camera, red light camera and the like, any death and serious injury there is just the individual's fault. But how many times can we build new signals and expect we're going to get some different result, but we don't? We just continue to see the residual death and serious injury. It's time we've got to start questioning that that process and what we're just rolling out. So better than a give way sign, but by no means safe. A roundabout, on the other hand, is much better aligned with safe system principles, passenger vehicle to passenger vehicle we're talking about here. And it's because we're addressing the severity of incident. Okay, now, I said 45% crash reduction factor for traffic signals. We can be somewhere in the 80% when we're talking about roundabouts, depending on a few specifics of configuration and specifics of road users, but generally around that 80% reduction in death and serious injury. We have about the same number of crashes, though. It's just that they're not as severe. But you can see that the land take we need is big. Somebody had pointed out there that they wanted to do it. They didn't think they could afford it, but they wanted to do it. And that's a fair comment. You know, it's big land take, big area for larger vehicles to be able to go around on this one. So you can see. And as you add the second lane to it, it starts to be more expensive, but it's also, you're starting to lose a little bit of the advantage of it. But maybe we don't need to be as big with it. Maybe we could go smaller. And this is a very different road environment to what you were looking at. But I point this out for a couple of reasons, actually. This, it's a funny little roundabout, but one of the biggest reason we do see a really good safety benefit from these mini roundabouts in the UK is because of disruption of absolute priority. And what I mean by that is everybody approaching this intersection feels there might be a chance they have to give way. So they look around, they slow down, they're more attentive, they're alert. Okay. If we have a priority leg, and it can be even a priority leg with a green light. So an intersection signalized, you've got a green light, people are tuned out, they're going at the same speed, they're not activated in the driving task, they're just driving through. And so if that vehicle enters, we have high speeds, we have bad angles. Here, we're at least more alert, and often people are slowed down to go through there. Okay, so disruption of priority is quite a good concept. I mean, the idea of a four-way stop, which is used a lot in the US, is a very well thought through technique, because you've got your point of risk and everybody slows down to come to it and then carries on through. These mini roundabouts are sort of the UK equivalent of a four-way stop. And I think these are things that we should be investigating a lot more in Australia. If you're worried about approach speed, straight lining through, you can look at slowing vehicles a little bit down on the approach, but we can see some really great options, maybe not as exorbitant cost as we've been thinking with these full-size roundabouts in conformance with Austroad's Guide to Road Design Part B. And roundabouts, as we talked about, really beneficial for a handful of reasons. One is reduction in conflict points, and especially reduction in severe conflict points. So you can see their conflict points, ways that cars can crash, car to car. We haven't put in pedestrians and cyclists at this stage, because we're going to talk about that next module. And these rural roundabouts, or these areas where very low pedestrians, we see that small number of conflict points at a roundabout, more conflict points at signals, ways that they can crash. The angle of crash is much better. When people crash at a roundabout, they bounce off. They crash at signals, it's a very harsh angle for crash into the sides of vehicles. As I mentioned, people are driving in all states of consciousness. Sometimes they're half asleep, they've worked a double shift, and I don't know, they've driven for 10 hours, and then, they're on drugs, they're on their phone. There's all sorts of states of consciousness people are driving in. You can get angry at that, and you can just push all of the blame back to them. Or we can start saying, well, are there things we can do with the design of the road environment, and actually miraculously a roundabout at a intersection brings them back to an active driving task. They're looking around, they're navigating, they're looking out for other vehicles, and they're really involved in this. But signals, you don't get that as for a proportion, that they're very tuned out to the task of driving through a very higher risk spot on the network. So it activates the driving task at that point in time. Jump into that, Marissa. I'll let you answer the question, but it reminded me of a memo that I wanted to show when I was talking about this. So I'm just going to stop sharing, and I'm just going to dig in and see if I can find something, if that's all right. Do I have any questions?
Yeah, all right, sure. Well, while you're looking for that, we've got the crash heat map, Ken, that you were showing. Is that publicly accessible?
So most jurisdictions around Australia and New Zealand, you can publicly access their crash data. And then to heat map it, you can either use ArcGIS or something like that. Well, there's plenty of available softwares. You can just drop the extracted Excel in, or Excel these days has its own built-in heat mapping function in 3D maps. So if somebody's interested in that, I can give them a quick tutorial on how to do that, depending on which jurisdiction you're in. I just was dropping some of that into Queensland's data recently, just doing it. But here is here's a copy of a memo that we were writing. Now, I've got to give you the story behind this. It's back in the Road Safety Department in Vic Roads, quite a while back now, and there was a big congestion easing program. It was called Keep Melbourne Moving back in the day, and the traffic modelers and the like had come up with, this big model and said, okay, here are the spots, and if we can, fix these with infrastructure, we're going to make this improvement. And the bulk of the projects, well, not the bulk, quite a few of the projects involved removing a roundabout and replacing it with traffic signals. You can get a little bit more out of the network during those peak times if you do that in terms of car flow. And so they were coming in to us to review from a safety perspective, and what they were sort of expecting, I'm pretty sure, was, just, is the phasing right, and do we need mast arms, and these sort of things. But we started putting these memos on, so doing some simple calculations, road safety style calculations, and putting in there. So the Road Safety Department has analysed this project, increasing crashes as follows: project life, 20 years or whatever, we decided the life of the infrastructure would be. Number of deaths attributed to this project, 2.3. Put the people there just to remind people that's not just a number. We can kill some people here. And seriously injuring 12.6. And statement of acceptance, it's accepted. This road trauma is accepted by, and so that would go on the top of the memo with all of those other notes about the other bits and pieces, and sent back. So the thing is, we know that we're going to increase risk, and of course nobody signed it, and there were phone calls to executive director, and then there was meetings and the like. Yeah, well, yes. Okay, I remember vividly being, this stern conversation of, the role of a road authority is complex, and you've got to manage many different things, and we've got an obligation to blah, 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 blah. I'm like, we know that, but okay, if we also know we're going to kill and seriously injure people, say that it's more important to get a bit more capacity out of the intersection, and that we will accept killing and seriously injuring people. Okay. And that's then the philosophy. Don't sign up to the safe system philosophy and then go, yeah, we'll do that if it's convenient. Yeah. Anyway, I think you get the idea. Anyway, we weren't allowed to do this with memos anymore. And I didn't get fired, by the way. It's not why I don't work in government anymore. I very much love working in government. But I'll show you later, there's been some good progress in this space, which means we don't need to write those sorts of memos anymore. Oh, it's come back again. I've gone to the wrong screen. Can you see the yawning person?
We can definitely see the yawning person.
Yeah. I wonder if anybody yawned when it came up. You know how when you see somebody yawn, you yawn?
It's gonna, yeah. Look, don't be surprised if you get a yawn out of me in the next 30 seconds. Should I touch on a few of the questions and comments before you go on there?
Oh.
Andy has said, yes, but what about the cyclists and pedestrians through roundabouts?
Yeah. So I sort of taking it one step at a time, and I'll talk about cyclists and pedestrians at roundabouts in the next module and how we can sort of do that. Certainly we know there's some challenges there, not just from a safety perspective, but also a mobility perspective and a permeability perspective.
All right. Okay, so the smaller roundabout, the higher the impact angle due to less deflection. I see that it would have lower speed environment though. It would have a lower speed environment, sorry.
Yeah, and that's right. So we're thinking about a range of factors in roundabout design and impact angles and speed on the approach and all sorts of things. So that's good. Yeah, I'll talk a little bit more about that later as well.
Yeah, Andrew, the memo is brilliant as an ex-government employee working in this space. Lots of exclamation marks, and we can confirm we got a yawn out of Brendan.
Okay. I'm going to have to work to keep everybody awake now, am I?
Yeah. No more yawning slides, maybe. Fast forward 100 years, authorities have adopted safe systems into everything, but do not want to revert to roundabout after signalising due to traffic warrants. Oh, it just disappeared. What happened? Sorry. Due to traffic warrants and cost, no doubt. Does the future possibly have signalised roundabouts so you get the best of both worlds?
The future's here. We've got signalised roundabouts. We've got a good amount of them. I did a safe system snippet on signalised roundabouts not that long ago. Maybe, Marissa, you could just jump onto our website and hit the search signalised roundabout. See if you could find that to show people a little bit later on. But certainly I've always advocated for not dismissing a roundabout just because it's getting close to capacity at particular little points in time. And in fact, if you actually take a roundabout over a 24-hour period compared to a set of traffic signals, even if it's got a few hours of the day where it's not performing particularly well, the hours of the day that are not congested, you're getting that continuous flow. I mean, that's the original intent of roundabouts, was to continue the flow. So at a 24-hour period, you actually get really great benefits, but there is going to be that little bit of time. But you can start to meter roundabouts. Metering is putting signals on some legs, or you can signalize the whole lot. But anyway, I'll talk a bit more about that, and maybe we will show something on the screen in a little bit. Okay, I'm going to keep running through because I realise we've got to tell people about their assignment too, Marissa. So I'm only 6 hours behind in this 2-hour webinar, so that's pretty good.
All right, we'll keep going for now.
Okay, I can jump through this pretty quickly because this is more a little bit of adding interest and a bit of thinking, but somebody mentioned angle of crashes, and there's also multi-lane roundabouts can be straight line through. So we lose a little bit of safety performance. And turbo roundabouts I find interesting. I like them. They are roundabouts that have raised concrete or raised separators on the approach and through the circulating carriageway to stop the straight lining and some speed. So, you want to do a right turn, you get into your channelized right turn area. They basically perform as well as single lane roundabouts, pretty close to, yet they're a double lane, so you've got more capacity. So again, it's showing you we can have safety and capacity. We don't need to be trading off one versus the other. I love this photo because we've got, look, the truck has come in, obviously made a mistake, entered the intersection. We've got this white van here, and I know it's going to be safe. I know that white van is going slow because they physically would not have been able to navigate this radial roundabout design without slowing down significantly. And then if they do happen to hit this, the angle, look at the angle of crash. It's beautiful. So we're in, just a beautiful example of sort of safe system in action there. And then I popped this up, like we had a Dutch engineer that we were traveling around doing cyclist around a design of roundabouts for cyclist safety, actually. And I was talking to the Dutch engineer about this photo. I haven't been there, and I was saying, well, this just amazes me. Like in Australia, we would really, for those roads with those volumes and where it is and the like, that would be a large signalized intersection. It might at some point get grade separated, but it's going to be a large signalized intersection with speeds of 70 and 80 kilometre per hour. And we're seeing them, continuing to be built all the time. And the Dutch engineer, and this is 10 years ago, just was absolutely dumbfounded. It was like, at what speed? What about all the death and serious injury community? It was just, so they would rather this much land take this much complexity in order to keep speeds down at these conflict points. Now, actually, I don't think this would be that complex if you're on the ground, because you just sort of follow your channelized area and it's signalized around the outside of it anyway. So, but more to me, it was just the completely different way that we look at that transport system, in terms of we have these high speed, inherently dangerous locations where we push the responsibility to an individual to see a red light and stop, versus this, which is, lower speed, not without, some risk, but the severity is going to be bad. And the responsibility is still to, stop and the like, but you'll find it very hard to do, major significant damage to another vehicle and occupants of those vehicles at this location. But it's interesting to see people are trying to push to, how can we actually operate some of these major arterial to arterial intersections with more safe system alignment? So what could we do? And I'm liking to see some of these concepts come out. This is the cut through. It's not been built, it's a concept, but, you're trying to get that different angles. You're trying to wake people up. You're giving them an activation as they enter an area of high risk. So some interesting concepts. But it was really heartwarming to see quite a number of you went with a raised intersection, or raising the intersection in our little exercise, because certainly 10 years ago, nobody would have done that. That would have been, and in fact, it would have been just laughed at. But we know now a bit more about, ramp grades and how to place ramps and how to do these things. And we see that is actually where that region got to, because they said, nah, it's actually signals because of the size of a roundabout potentially, and the small one. We've also got unbalanced flow, and, we've got this side road with much lower volume. So we're going to get this weird traffic thing at different times of day. And we also want pedestrians to have some sort of crossing point, even though there's not a huge amount of them. And they landed on traffic signals, but they were actually finally at the point of saying, are we really just going to build one and expect we're going to get better performance than the one down the road and better performance that other one where we've had people seriously injured and killed? Can we do anything else? Can we actually address severity of crashes as well? And so that's why they went to slowing vehicles, using these shallow ramp platforms. And you can see they're down advisory speeds of 50. Okay, advisory speeds of 50. For a prize, why have they picked 50 of anything? Why not advisory speeds of 60 or 20, or, with appropriate ramp grades, so that, the steepness of the ramp you can change, which is going to elicit a different speed response. Anybody, why on earth 50? Okay, kinetic energy threshold. That'll do it, Matt. we'll do it. Matt gets prize as, and it's kinetic energy threshold for a right angle crash. And then that was what you're worried about. We're worried about a vehicle coming out here, being struck by a bullet vehicle and slowing that vehicle down to a point where we think it's highly likely that everybody will survive. Okay, admittedly, it's not getting us to our threshold speed for the pedestrians crossing. And that's, yeah, we can maybe work on that a bit. And we probably need to think about a land use function and why we're having pedestrians and trying to mix with major arterials and have we, but I think that's a pretty good outcome. So I was out with a colleague doing the post-opening road safety audit of this Surf Coast Kidman Avenue. I love this photo. Green light, vehicle slowing down, approaching the conflict points. Beautiful. Showing this to some people who are traffic ops people, and they were grumbling. Oh, I don't like it. It's so inefficient. I'm always slowing everybody down just for this, this risk for only a very few. And I'm like, are you kidding me? If we put a roundabout in there, which was a genuine option, you wouldn't be complaining about everybody slowing down. It's just because this is new and different. Like that, So, yeah, it's just, it is new and people get, people don't like change, do they? I also like this photo because it reminds me that we actually see some benefit in dilemma zone reduction. So the dilemma zone is the official traffic engineering term for the point in time and space when a vehicle is in a dilemma as to whether or not to put the foot down and go, or brake when the amber light has appeared. And so dilemma zone significantly reduces when you put the raised platform in, because the higher end, the put the foot down, have all decided, no, I'm going to stop because I have to navigate over this thing. And it's been really good, some of the evaluations that have come out and some of the discussions with the people managing these roads and looking at the success of race safety platforms. And we're seeing them on like major roads like this one, Dalton Childs Road, and all of these ones, 55,000 vehicles a day on one leg and 25,000 vehicles a day on other bus routes, heavy vehicle routes, emergency vehicle routes. Like these are big roads, and raised intersections are performing really well. None of the things people were concerned about and like were big reasons to, you could never possibly do this. People are going to hit it and dukes of hazzard over, flying off into the houses. They're going to, it's going to be a maintenance disaster. We're going to have flooding and we'll have rear end crashes. And none of it's played out. The noise will be unbearable. The bus passengers will be flying off their seats, and none of it plays out. All that's happening is we're getting a reduced number of deaths and serious injuries compared to not having it raised, slowing vehicles down, just old vehicles slow down a bit. There's a bit of work to be done on ramp grade construction. Didn't quite get as to the what you were trying, but generally we're seeing really great safety performance out of these. So really, I think something, if we are genuine about actually operating a signalized intersection in a safe manner, we have to look at something to reduce speed. And it's got to be something physical, like even a speed limit reduction. While that's helpful, it's not giving us the physical presence there that people actually slow down on the approaches. Other pictures. Oh, the other reason I like this, really wish though this had been a 30 or a 20 for the actual slip lane ped crossing, but anyway, nonetheless. One of the other reasons I love this, because Dalton Childs, this intersection used to be a roundabout, and and there was a congestion easing program, and they decided to rip the roundabout out and put traffic signals in. Not much changes in 20 years. But the big thing that does change is that they had to do a safe system assessment. And the safe system assessment showed, with much more palatable information or way of presenting the information. If this becomes signals, there will be an increase in risk for vehicle-to-vehicle crashes compared to the roundabout. And some recommendations. Well, here's some ideas. You could keep the roundabout, or you could do raised platforms to slow people on the approach to the roundabout, or some other features, and they elected to do that. So there you go. It's sort of the same as that memo, but in a form that doesn't get everybody angry. So in terms of design guidance, some of you are probably aware of this. There's a good road design note, 0307, on how to do these raised safety platforms from a design perspective and some considerations. And if you're interested, there's a good Austroads document, effectiveness and implementation of raised safety platforms. There's a 1-hour webinar that goes with that. Maybe, Marissa, we can even find some of these and pop them into the learning management system so people don't have to go off Googling. And let me just show another one. Yeah, I've got time to just do this and whip through another couple of slides. So this is an intersection of two high-speed roads, and it's got the arterial road sort of going that way. And well, I suppose there's a bit of a story to it. This is a what is it, a Telstra exchange building, and it was going to cost like $1.5 million to move it, plus the land area required to get a roundabout in, which is what the preference was. So they went to a channelized right, no, it wasn't even channelized, a right turn lane, and some warning signs and other bits and pieces. That was where they were going. But again, it was like, can we do something to actually address the severity of crashes and really fundamentally change things? So this is where they looked at then this compact roundabout. And this is a roundabout, like the roundabout is actually just this very small bit in here. That's the roundabout. The rest of it is concrete apron. And you can see the approaches are straight. Okay, no reverse curves on the approach, even though this is high-speed environment. But they've used raised safety platform or some shallow platforms out here to try to bring some of that speed down, and worried about straight lines through and a bit more speed here. And then larger vehicles sort of track over this. So then we have that ability to have, much lower costs. So this ended up being about half the cost of a roundabout that you would have to design if you followed Austroads Guide to Road Design Part 4B, which is roundabout design. And so again, we're seeing like, what can we do to push here? So I'm sure some of you have seen this one down at Lance Creek in Victoria, compact roundabout. We've written some design guidance on compact roundabouts, which is available on the Victorian Government website. In fact, again, we might pop that into the learning management system so you don't have to dig it out. Goes through all of the complications associated with this, because there is complications, like, you can't put things in the circular, like in the roundabout, like lighting and those sort of things. You've got to think about your swept path of vehicles, and where your ramps are and where the lights are positioned, and all drainage, because you've got some raised areas, and there's a lot to think about. But it's again, I think if we can do this at half the cost of a normal roundabout, in fact, I think you can do it much cheaper than that. I think this one, because of a whole lot of reasons, and it being the first of its kind, and having to do endless stability analysis and checks and all these risk workshops and design exception, this and all of it, I think you could actually streamline this down to be even lower cost, and we'd and we could do a lot more of them. Okay. So some questions are in there around, so the guidance talks about ramp grades for all ramps. Has the first platform replaced the old rumble strips? Seems to have. It's more replaced your reverse curve, which is a well-proven way to start that slowing down process. Anyway, I'll keep going because I need to. I'm not going to do the quiz because I need to give you more time to actually be told what you've got to do. So lane departure, really, I mean, I can do this quite quickly, and I need to do it quite quickly, which is basically people fall asleep, they get distracted, they, drop their cigarette in their lap, and whatever it is, they leave their lane. And then we're just leaving them with high speed, and they leave the road, they hit trees, power poles, culverts, they hit other vehicles coming the other way. Again, the risk exists along the whole of these corridors, and there's little bits of increase in risk when we have little curves and side road accesses and the like. Major access points there is a big spike in risk, but we know that the risk is certainly there, and we know these side impact with point source hazards are extremely far from safe system threshold speeds. 29 km/h side impact whole test for an ANCAP 5-star rating. It's actually gone to 32 in recent years, but nonetheless, we're nowhere near that for the speeds that we're seeing vehicles leave the road and hit trees. Here's one that's estimated at actually more like a 60 km/h into power pole and actual impact speed. And you can see the just excessive violence in that in terms of energy transfer. It's unsurvivable. Kinetic energy formula just spits out massive amounts of energy with weight of vehicle speed, and that's what we see. So even clearing the roadside, getting your clear zone requirements, we know does something to reduce risk, but we know people go beyond clear zones and they find hazards, they roll over in clear zones. So we're never sort of getting much better than about a 4, down to about a 4 casualty crashes per 100 million vehicle kilometres travelled at a risk sort of threshold. So some dot points on the old clear zone way of thinking. Okay, we get our best benefit in about the first 4 to 5 meters, and then it's really asymptoted off that after that. And you've got to be concerned about hazards beyond and rollovers and the like. So, if it's a new bypass of a town or a duplication of a road into these, we're not anymore designing with like a big calculated clear zone across the middle and then a calculated clear zone out to your trees. You wouldn't have these in your normal design, because we know if we build that, people are going to get across the carriageway, they're going to have head-on crashes, they're going to leave the road, they're still going to hit the trees. Happens all the time. Okay, brand new bits of road, they're open, and then these things are happening all the time. So Guide to Road Design Part 6 is starting to move us more in a safe system aligned way of thinking about roads and roadsides, roadside safety, and really to sort of absolutely simplify things. Full containment with barrier system is where we want to go on any high-speed roads. All right, it's going to get hard with cost and brownfield sites and all sorts of other things, but that is our best alignment with safe system principles. And as we drift down here, we want to start addressing the actual travel speed of vehicles, and that will help get us better alignment with safe system principles. I better stop there, Marissa, because I've got 7 minutes to explain what on earth they're going to do with their assignment.
Yes, all right. Let me just share my screen now. Switch over to me and we can see that clearly, Ken.
Yeah, looks good.
All right, so module 2, everyone on the LMS. Like every module, we've popped the presentation from today up there. You can have a view of that PDF. The snippet on the signalised roundabouts is available here. You can just click on that link. That'll take you to our website. You can have a read through that. A few resources that Ken mentioned again on race safety platforms. We've got the OSRoad document there and a link to a road safety platforms webinar that you can have a look at. the Vic Roads Compact Roundabouts document is also there for you to have a look at. We've got our Module 2 quiz here. So, yeah, please complete that. If you got an idea to complete it after the session, that way everything's still fresh in your mind. So that's a task to do also for Module 2. And we have our Module 2 assignment here. So if I'll just click into that, I'll let you explain the assignment, Ken, and then I can talk about submitting that.
Okay, so you've got a PDF there, and it's one of those editable PDFs. You'll see there, you're going to put your name, obviously, and there's instructions. Very nice, thank you. There are instructions there step by step, so you'll be able to follow them. But what we want you to do is pick an intersection, and we don't really care which intersection it is. It could be one outside your house. It could be one you remember, one you've got a concern about. It doesn't really matter. You're not going to need to go there because we're happy for you to just, at least for this exercise, use Street View. And you're going to give us a link to that intersection or the coordinates of it, or just something so we could jump in and have a look at it via Street View ourselves, okay? So then you go further down. So you've picked your intersection. And you'll see there's 3 columns there. There's exposure and likelihood and severity. And what we want you to do is in the green cell there, put in between 1 and 3 factors that influence exposure. Now, remember, exposure is the number of vehicles. So, that could be something like it's a high volume road. As simple as that, right? That's going to influence exposure. You're going to have lots of people exposed to crashes. So between 1 and 3 factors there, then you go over to likelihood, and you go between 1 and 3 factors that influence the likelihood of crashes at location. So it could be, sight distance to the intersection. It could be the, sight lines. It could be confusing signage, could be bad surface treatment, whatever you're noticing out there that is likelihood. And severity. Severity then, between 1 and 3 things that is influencing the severity of crashes at that location, could be the, speeds or angles or whatever it is. And once you've done that, you go down, and we just want one thing that you could change that would influence the exposure to crashes at that location. Only one thing for, your proposed alterations. Now, you're not budget limited on this one or anything like that. So you can just put in whatever you want. And then you do 1 for likelihood and 1 for severity. And that's all. Now, just what are we sort of testing you here on? We are testing you here on your ability to categorize into exposure and likelihood and severity. Right? You could suggest whatever you want as long as it's categorized correctly. Now, we won't mark you down if it's something, we look at the intersection, we go, I don't know if I'd do that. We might make a little comment, but we're not going to take marks off you as long as you said, I think we could change this and it will influence the likelihood. Okay, if you got that right, you'll get your 100%, regardless of whether or not, it's an appropriate thing to do. So you save that, and then what do you do?
Yeah, so the due date for this one is Monday the 29th. So if you could get that in by Monday, that will give Ken a chance to have a read through them all and even have a chat about it before our next session next Tuesday. So fill in that PDF, save that, and if you can just click on, you'll see Add Submission here. You can click on Add Submission, and you can just pop your file into there, save that, and that will upload into the LMS in your profile, and we'll get notification of that and we can have a look. So just again, in Module 2, it's just here, the Safe System Module 2 assignment. Here we go. Great.
So anybody got any final questions in our last minute, just to check?
We've got, is the first row for existing and second row for design suggestion?
Yeah, basically, yeah. I mean, the first row is, what is out there? What are you seeing? And then the second one is, what's some changes that could be made to influence that? So if you want to call that design suggestion, that's fine. Yeah. Awesome. Good work, everybody. And thank you, Marissa. Wonderful work. And we'll see you in the next module a little early for more trivia.
Yeah, absolutely. See you next Tuesday, everyone.
Bye.